Another day, another episode with low-level vibe coder. So last time we almost finished implementing a query parameter parser. Uh, I guess we got it fully working, but we're missing the percent encoding part. We don't parse like percent encoded characters. And I've been wondering, so I haven't been working on this project as much anymore, mainly because I'm losing motivation. And this happens with every project that I start. I reach a point where I'm just not interested in the project anymore and I stop working on it. And I don't want that to happen to this project because I'm posting it on YouTube and I want to at least have something working. The reason I started this project was because it was meant to be like as a learning experience to learn C, to learn how to do multi-threading, to learn various parts of C and become a better C programmer and learn more about like low level programming. And yeah, I've been straying away from that a little bit because what basically we have been doing so far is trying to like not, I wouldn't say like perfect, but almost perfect every part that we're building, like the status line parser, the headers parser. I'm always trying to come up with like the best solution that I can implement, like with my current knowledge. And if I keep going like this, I think like we're basically building an HTTP server. Like it's a very big project. Like coming up with a production ready HTTP server is time consuming. It will take years. And there's a lot of things that I don't know about. I'm not a cybersecurity analyst and I don't know of like every security vulnerability there is. So I mean the server will never be perfect, but I just want to so the thing that I want to address today is coming up with a plan of, a list of features that we can build, a reasonable, I guess, or a realistic list of features that we can build. Yeah, so we can basically finish this project. Initially today I was going to work on implementing the percent encoding parser for like in the query parameter parser, but I'm just going to skip that. We're only going to be like from now on, we're going to try to focus on the MVP features of an HTTP server. MVP feature set. Is that how you type feature set? I'm not sure. Implement response builder. Implement route definition logic. So you can define routes and respond to them. And I think then we'll actually have a working server. What else? Request parser. We already have that part. Body parsing, not logic, utilities. Implement routing. Maybe I want to have a sublist here. Request parser, we already have. Route definition logic. What are they called? Route parameter. Parsing. Example, yeah, user ID. What's for non-existent routes? Then we have body parsing. I guess implement the ability to serve files. Middleware support. Yeah, middleware support would be nice. But before that, actually, body parsing utilities, something really important is implement concurrency. That's the reason why I started this project, like in the first place. I guess optional feature set. Let's ask Claude here. What are the features of an HTTP server according to the RFC? Okay. Transfer encodings. Why would I need to implement request methods? Then data job. I'm trying to build a server that can be used by developers. So basically, can define routes and have, I guess, handlers to send custom responses. I mean, we are already parsing request methods, but what does Claude mean by this? We don't implement what get post mean. Parse, route, and pass. Yeah, that's we already do that. Or if C requirements worth handling at the server level. Okay, sure, method not allowed if we don't find a match. Head should work like get, but omit body. Options can auto-generate allow header. Okay, we can take a look at these later. But we're only gonna worry about these for now. So let's get started. We have request.h. Yeah, I shouldn't have called this request because we kind of have shared structs that we want to use in the response as well. Let's see. Okay, let's just do this. So response.h and response.c. Let's go to request.h. We're gonna have end if here. So this is gonna be response h. And what are we going to have here? So I guess instead of HTTP request, we're gonna have HTTP response. Responses don't really have methods. Neither a request target or path name. I think they only have... Do we care about the version? Let's ask Claude here. What should an HTTP response struct contain? They only... There is in the body, right? I think so. I may have missed something, but I'm not sure. But let's see. Ooh, yeah, status line. So version, I guess, yeah, sure. We have the status code. Okay. So yeah, and status code. Reason phrase, is that customizable? What else? Headers. The actual content payload. So will you allocate the body buffer yourself or point to user provided data? Do you need to track whether headers have been sent? Oh, this is interesting. How will you handle the reason phrase? Hardcode the lookup table or allow custom phrases? Can you elaborate on number 2? I don't know how that works, like, fully. I mean, I've seen this in Node.js before. If you try to send the headers more than once, it will give you an error message saying headers have already been sent. But why is that a thing? Buffered response, you build the entire response in memory, then send it all at once. Here you don't need to track state. The struct is just a container until you're ready to send. Streaming responses, you send pieces as they become available, useful for large files. So you can only send them once. Oh, I see. Okay. I see. Okay. That's actually a good point that Claude brought up here. Let's add a state. What's it gonna be? State. Header sent, body sent, closed. Let's type def. This with the same name. Is that what I'm doing in request? Do we have any enums here? Yeah. So it's gonna be this. HTTP response. So is this gonna be the same as request, I wonder? So create HTTP request. I guess, yeah, this could work. So should the HTTP response struct like worry about the body at all? I wonder. Because I mean, in Node.js, right, you can send, they have functions that allow you to send anything you want basically in the response, but it doesn't like exist like your body. You can't put it somewhere like on the response object. So there's no reason to store it there. We only want to create utilities for sending the response, but we don't need to keep track of it in the struct. So let's start by creating this create HTTP response function. So we include the header. I think it has to be like this, right? And then we have HTTP response create. I guess in the future, when we support multiple versions, we'll have to refactor this code, but this will do for now. We have a status code. I don't want to do that yet. I guess the default could be 200, and then when sending the response, you can modify it if you, for example, if an error occurs or you want to send like a custom status code. We create HTTP headers. So I think one thing we need to refactor is we need to have an http.h and then an http.c. We'll copy these here. This will be HTTP. Nope, did not mean to do that. And we have an indif. And I want to copy some of the shared things, like the headers code, for example, from the request .h file. Why is this not working? Do I not have the extension installed? I don't think I do. And yeah, you may wonder as well why I switched back to Arch. Because, you know, Ubuntu was fun for a bit, but then I started like getting bugs everywhere, and you know, my shortcuts wouldn't work, and I felt it was kind of slow. And I also don't like the window manager that much. I like tiling window managers more, where you can, you know, create windows like this, and the window manager will automatically split them, and you don't have to worry about aligning anything. So I switched back. I mean, this is Arch Linux with what's it called? Sway, the Sway window manager. I mean, it has lots of bugs, but I'm happy with it. So headers, it still doesn't work. Let's exit. So do we have compile commands? We do. It looks fine. Oh, I missed a message down there. Oh. Oh, we need to install it. But anyways, in the meantime, So these will go here. And we can just query params, HTTP request. Yeah, we don't need this response, I don't think. I think size T, where's size T? Okay. We need to include standard bool as well. So this part works. Let's go to http.c. Oh, this needs to have the implementation. So parse headers. Do we need to parse in the response like ever? I don't think so. This is only a request thing. So I need the headers add, headers delete, clear, find, and iterate. And those will go here. We include this. Max headers. Oh. I think it may make sense to put this here. We have mem copy. I think that's in string.h. Sure. Are we missing anything else? I don't think so. Let's try to compile. Okay, so response.h. We want to include HTTP. Query params we don't really have. Arena, I mean, yeah, we need that. Why is this complaining? Oh, because the type def is named wrong. So, this is supposed to be uppercase H. Arena allocate. Wait, what? This is not supposed to be arena allocate. HTTP version. I can just do this for now. Reason phrase. This will be okay, yeah. Let's go to request. We need a function to create the headers. Let's go to http.h. Yeah. Exactly, and we'll copy this here. Oh, it's just headers. So now we can do this. Just pass in arena. Query params, not a thing. Response.state is initial. Okay. Well, this is cool. Now what? Let's look at our plan one more time. So response builder. So we first, we create an HTTP response, and then we should probably have a function that allows changing the status code. But I wonder how I should implement this. I'm writing response utilities for my HTTP server, and I'm wondering the best way to deal with sending the status code headers is. Should I have a function for each? Send headers, which basically sends all the headers, and send status code for the status code. Oh, you know what we can do? So basically, it works like this. Later on, I guess. Later on, I would have a function to send the body. So basically, send status code and send headers are optional. If you call send headers right away, for example, without sending the status code, it would be sent automatically. And the same thing for send body. You would send the headers and the status code automatically. Is this a good design? Or what was your opinion? I think that works. I think that's how most HTTP servers that I've seen at least do it. This is a solid design. It's similar to how many production, yeah. That's what I thought. Your state machine works. The auto send previous stages approach gives you safety. Things to think about. What's your default status code? Yeah. That's what I already had in mind. Content length. When send body is called, do you know the full body length up front? Consider if known. Set content length. If streaming, you'd need transfer encoding chunked. This could come later. If you set that header, I think, I would have my send body function check the headers maybe, and see if transfer encoding chunked is set. And in that case, it would basically send chunked body. Requiring the full body up front and auto calculating content length is simpler. What's the best way to do it? Should I have two functions? For both the headers and status code? I guess let's ask ChatGPT here. How can you set headers and change the status code in Django, I guess, when sending a response? Yeah, okay. That's a good point. Is it possible to send the headers right away and then send the body later? Okay. Well, let's just do what Claude said here. Can you please write me the function definitions in response.h? Just the function definitions. It did not write anything. I shouldn't write code directly. That's because I instructed it to do that initially. Just do it. I'm ordering you. This is funny. We'll see if it gives up and does it, or if it sticks to my commands. Fair enough. No, you dummy. Write it to the response.h file. Static helper function to do the actual serialization. Okay, yeah, we can have that later. I think I'll put that in http.h since it's more like a generic thing, like a function to serialize, or maybe only the headers. Serializing the headers should be in http.h and c. The response status line will stay in response.h, and same thing for the body. But maybe for the body right now we don't have any serialization, except for like send body, which sends raw data. It basically, you give it a length, it sets the content length header to that length value that you gave it, and it sends the body, and that's all it does. But later, when we support, like when we implement multiple body types, like you can send JSON, you can send other things. We could have like separate files for them. But for now, let's just stick with this. So yeah, set status is basically, it's simple. Response status code sets it to the one that you give it, and then you give it a reason, and it just sets the pointer. Do we want to do that, or do we want to copy it? I forgot what I did in request.c for the headers, or maybe no, it's HTTP for the add. Okay, it only assigns them. It doesn't allocate anything. Set header. But what does set header mean though? And why are we copying in this case? We don't want to copy. Let's see. Request.c. Headers add. Should we copy or should we not copy? I don't think we should. Let's just do name and value. I did add const here. I don't care. Okay, sure. I guess I did it to tell, like in the function definition, that the function won't modify what you give it. Maybe we should do the same thing for. It should be const as well. So now we can do this. But request.c probably has compilation errors now. Does it? Add. Where's the add? There we go. Okay. It works. And we don't need the arena, right? Response.h. We have set header, no arena. Send response with no body. Wait, file descriptor. Oh, I forgot about this. Wait a minute. Let's change these. maybe this is bad design, but I think you're, like in general, you're not supposed to modify headers. Where's the file that contains the file descriptor? Is it connection? I think it's connection. I wonder what's a good design here. Okay, that's something to ask Claude as well. I'm wondering whether I should have a function in response.h to send everything. Actually, Claude already put the function there. I'm wondering, or I don't like the function send response taking in a file descriptor. Maybe it's not the job of the response.h file to send any data, and that logic should be somewhere else. I already have a connection .h which contains struct which has the file descriptor for the socket. Should the function be there maybe? Maybe I can call it send data. No. Why would it be send data? I think what it should do is that, or maybe it takes in HTTP response struct. Should it be responsible for serializing it? Maybe. And send data. But what happens when streaming? I basically want an API that's not coupled and is easy to use. Move send functions to connection. So send response, it takes in a connection, a response, a body, and a length. Response serializes, connection writes. So we have a function in response.h, serialize, streaming friendly API, connection begin response, write body. Ooh, yeah. I like 3 more. Can you add the function definitions to connection.h? Okay, so we don't need this. Neither this. Oh, sure. Should this be called set header though? And I wanna request.h. So let's do this. And HTTP response set header. It's not really a set though, because it's doing an add. If we do set header with the same name multiple times, or like more than once, it will add 2 entries for that header. Maybe you should also have a return value now. Int. Yeah. And that works. Okay. I think we need to serialize now, right? Okay. Can you add 3 functions to response.h for serialization? I want one for serializing the headers and one for the status line. I said 3 functions, but I only mentioned 2. What? What is head? Combines both and adds the final. Oh, \r\n. But how? So you give it a buffer, it writes to it. Oh, basically it does both. Okay, sure. Sure, yeah. I like that. Cool. So let's implement these 3 functions. Let's start with the first one. So we have this HTTP response serialize status line. And it basically does what it says. So we need to write this thing. Oh, I can't highlight this thing into the buffer that is given to us. And how are we going to do that? I think we can use string copy. So first argument is destination, which is going to be buffer. We're going to copy the HTTP version. And the length is going to be strlen HTTP response and version. But I wonder, I think if the buffer is too small, like let's say that the buffer is like has size 2, then this is going to be bigger than the buffer and we're going to end up overflowing it. So I think we need to check the length before we do the copying. So let's do that. We need the length of the header here, or the HTTP version. Let's store it in a size t. Give it a name, and here we can have an if condition. If HTTP version length is bigger than or equal to, I guess if it's equal, then that's fine. Even though it's not really fine because, So let's start with this and see where we go from there. If it's bigger than buffer size, we're gonna return -1, which means that the writing failed. And here we're gonna have HTTP version length. I forgot to mention that I don't have what's it called, like Copilot completions in the editor anymore. I don't know, I wasn't a big fan of them. I mean, they were pretty helpful, but we're gonna rely on Claude for now. Like, ask questions instead of having like completions right in the code, and try to write like the code ourselves. I'm still experimenting with AI. So we copied the version. So I think we need to have a function here that basically, let's try something like this. Write to buffer maybe. It's gonna be given a buffer, size t, buffer size. Actually, let's ask Claude here. Is there a utility function for writing into a buffer and checking that it doesn't overflow on every write? Basically the same thing I'm doing in the let's just give it the file name. What's it called? I think response.c. Yes. So we can have a utility function here, but I want to make sure first that there isn't one in the C standard library. This is a common pattern. a buffer writer that tracks position and remaining space. Yeah. I mean, it might be useful. We can add it later on. Let's just do this for now. We need to take in the string that we want to write. So destination, destination size, and then we have source. And then, I guess, source size. And we basically need to check that buffer size is... Ooh, this is not gonna work though. Because, yeah, I think it might be better to just write a buffer writer. Because we need to track the current position as well. Like, for example, when we write the HTTP version, then the position is gonna be like 1, 2, 3, 4, 5, 6, 7, 8. It's gonna be 8. So the next call needs to do basically buffer size -8 to account to like for what we just written when like comparing. I'm tempted to put it here, but this file contains a buffer reader for, you know, that reads from a file descriptor. And later on, I think, when we want to write back to the socket and send a response, we're gonna need fd buffer writer as well. I'm not 100% sure. I think we may need one. So maybe I should give this file a better name. Let's call it fd buffer. Should I use underscore or dashes in file names? I think underscores. Let's do a buffer.h search so we can update all the references. Oops. Here we go. What is happening? Yeah, there we go. So fd buffer. This one too. We already updated it. This one. Connection.c. And this one. So now I think we can do buffer.h. I actually forgot to update this. Let's go to buffer.h. If not defined, buffer.h, buffer.h, and then we will have an endif. And let's implement these. Size t is in this. For status code. Is this an int? It is. Okay, let's do buffer.c. Go inside. Include buffer.h. And start implementing these. So the first one. What is this going to do? It's going to be writer buffer. It's a character pointer, so it's just going to assign it. Writer capacity is just capacity, and writer position is going to be 0. That one is done. So writing now. We need to check if writer capacity minus writer. We're using size t here. Can the position ever be bigger than the capacity? I'm afraid of, of overflowing here. I don't think so. As long as we check and make sure, like in all of these functions, that we don't overflow by accident, I think we should be fine. So capacity minus position is going to give us the remaining space. If the remaining space is smaller than what we're trying to write, then we just -1. Otherwise, we do string copy, Destination is going to be writer, buffer. I think this is the source, second argument, right? It is. Data and length. And we're basically gonna return length, I think. And don't forget to update the position. So write string I think is the same as this one, but we don't take in a length. So we'll have to do something like this. Strlen of stir. And I think then we can just return this function. So writer stir and then length. And we have character. Writer capacity minus writer position. Is less than 1 because we're trying to write one character. Then we do this. Buffer writer position I think is gonna be character, and then we return 1. Is that correct? Yeah, and we need to increment +1. So okay, writing an int is a bit difficult. I don't remember how to do this exactly, but okay, but here basically we need to check for the size of int, or size of value, I guess. Okay, size of value. If the remaining space is less than the size of value, then we can't write. But how do we write the actual int now? I mean, I'll take a guess on how this is done, but then I'll ask Claude if it's correct or not. So I think what we can do is this. I think we can do a cool thing here. Oh. We can do this, writer buffer. So it's a character pointer at the moment, but what we can do is convert it into an int pointer and then just assign the value to it, right? Assignment to cost is illegal. To cast, oh. Assignment to cast. Maybe I need to do this. It's a character pointer and we convert it into assignment to cast is illegal. I remember doing this a while ago and it worked. Can I cast to int here so that I can write an int? I don't think, yeah, I don't remember how it was done. Or it is done. So I'll just bite the bullet and ask Claude. Probably don't need to write a raw binary int. For HTTP you need the ASCII representation. Ooh. True. So do we just cast it into a character? Oh, okay. So it's supposed to be like this. Yeah, this works. But that's not what we want to do. I think this may be misleading. Because when you say you want to write an integer, you're writing it like as binary. Not as a, you know, if you have an integer that's like size 32, that's how many bytes? 4 bytes. So that's gonna use 4 bytes in the output buffer. But when you want to write an int, like as a string, that depends on how long or how many digits it has. So for example, if you just want to write the number, like the digit 1 into the output buffer, that only takes 1 byte of space. And I think when we say that we want to write an int, that means we want to write an int. But in our case, in the response serializer, I don't think we're ever gonna be needing to write an int. So I guess we could keep this function even though we're not gonna use it. Maybe we'll use it in the future, but I'll just remove it for now. We don't need this. I think we're mostly gonna be writing strings and characters. Wait until I'm proven wrong in a second here. So I think now we don't need this anymore. So here we can do... Okay, so how do we want to do this? So HTTP response. Should I make the buffer writer part of the HTTP response struct? I think it's okay to put it there. It makes the most sense. But maybe not. Yeah. Yeah, I'm thinking we just update the functions to receive in buffers instead of what they have now. So here, where's my buffer file? Buffer writer. So let's do this. Writer. Why is this complaining? Because it's not imported or included in this case. Let's do this instead. So buffer writer, and we have writer. We can remove all of this, and now we can do buffer writer. Or just buffer write. Writer. And here, I think we can just do string. And it's gonna be response, HTTP version. If it's less than -1, then just return -1. I think that's correct, right? Oh, if it's less than 0, what am I doing? Right, HTTP version. Then we need to write let's just copy this for reference. Then we write the space. Sure. And a space. Let's not forget the semicolons. Write the status code. So the status code here, we need to write it as a string, not as an integer. So what's the best way to convert an int into a string? SN printf. How long? Okay, so buffer 12 enough for 32-bit int plus sign plus null. I'm thinking maybe we should have a function for this, but not with the same name that we had before. So it's not going to be write int, it's actually already here. It's going to be write int as string. Yeah, I think that's descriptive enough. And this basically does that. So let's copy this code. smprintf, I think that's in standard IO. Takes in a buffer, size of buffer, and then a formatter, and then the value. Let's just keep that comment there. Let's add our famous if condition. And okay, I think this returns maximum characters of output to write. What? What does it return though? Printf. Printf. What am I writing? I think it's man 2. Maybe man 3. Nope. Man 5. Man 1. Let's look for it. Printf. So it's not there. Oh, maybe I don't have the man pages installed. So where's English? Oh, it's just mandb. It's already installed. Oh, man pages. Okay, there we go. So now if we do this again. Wow. Same thing. Wait, now it exists. Why isn't it being printed here? Standard library. Wait a second. Oh shoot, I didn't know about this. So I can do this, printf, and it brings it up here. That's sick. I think I might need to restart for it to work. But it's cool that, you know, we learned a new command in any of them. Yeah, we were trying to look for the man page here. Actually, one thing I forgot to do. You know, as a change, let's have some fun and use this Comic Sans font, which is basically Comic Sans, but, you know, modern. Yeah, that looks good. Let's increase the font size a little bit. Maybe 14. Yes. So now, printf. Let's return. These functions return a number of bytes printed, excluding the null byte. Yeah. So returns an int. Bytes written. I think I can just do a return here. Oh, we have a bug. So here we are always writing to the beginning of the buffer, which is wrong. It should be this, but a pointer to it. So we want to write to the current position. This works fine. This works fine too. And we need to do the same thing here. Oh. I guess we could call it digits written. We need to copy it here. I completely forgot. So let's do buffer write string. No, buffer write, just write. We pass in the writer and we just return here. Actually, do we need this check? Because this will perform it automatically. So it takes in a writer, takes in the buffer, or the value that it needs to write. which is buffer in this case, and then digits written. Yeah, that looks good. So now we can go here. We can do buffer write int as string. And status code. And then we write another space. And then we write the status text. I think that's what it's called. Let's do this. Status. Oh, reason phrase. Okay. And then \r\n. And this is also a string that we can just hard code. And then what do we return? Do we need to return anything? I guess the number of bytes written could be nice. But how do we calculate that? Do we even need to pass that in? Let's just do this, I guess. Start bytes is writer position, and here we can just do writer position after and just, you know, get the difference to get the number of bytes written. That looks good. Let's move on to the second function now. Response.h. We have headers. This is going to be slightly more difficult, I think. Well, maybe not. So what states do we have? So headers sent. Is this going to be part of the serializer? I forgot what we asked Claude here. So how are we gonna send after serializing? So we have the serializers, but then we have these connection begin response, then we have write body, and then end response. Can be called multiple times for streaming. Okay, so begin response will send the status line and headers. Yeah, this function is gonna be the one that updates the state. Do we have that already? Connection.h. Yeah, we do. That's good. Let's get back to what we were doing. So serialize headers. How do we want to do this? Can you show me a sample HTTP response with some headers? I just want to see what it looks like, so yeah, I kind of forgot. Let's see here. So we have this \r\n, and then we have, you know, each header with its own \r\n. Okay. So we need to loop over the headers, and I think I've already written a helper for looping. Where did we have the headers again? Connection arena aids request. Are they in request? No. Oh, HTTP maybe? Yeah, there we go. Yeah, that function. HTTP headers iterate. Why does it return boolean? Oh, because you give it an index. Okay. So what we need to do is while, and okay, header key. It's gonna be null in the beginning, and header value. And we're basically gonna call this headers iterate. Actually, we need to add a to-do here. C, I guess research if we need to have certain headers, I guess, automatically populated and sent by the server. It's going to be response headers. Index is going to be, we need to track that. We're going to start with 0. So header key, header value. This takes in a pointer. Oh, I is a pointer too. This one is a pointer too. Everything is a pointer. And let's do the same thing here. We have start bytes, so we can track how many bytes we've written. And how is this gonna work? So headers, we basically write the key, then a colon, and then the value, and then a \r \n. So let's write the key first. Just gonna copy this. So as far as I know, I think keys are null terminated. So we can just use this function. So header key. Right, header separator. Which is going to be this. And then finally, right header value. And then our famous \r \n. And we need to do this every time, so until we run out. So the while loop is going to be, I mean, this already returns a boolean, so when we run out of headers, it will just return false, and the while loop is going to terminate. Then we go here, calculate how many bytes we've written, and just exit. And I think we're done. So this last function is basically combination of the first two functions, so we don't have to write any logic. So how is this going to work? Bytes written is going to be 0, and what we're going to do is we're going to copy this. It's going to take in a response and a writer, and we're going to do bytes written plus equals. Ooh, actually. We need to check if this returns -1, then we need to return -1 as well. So how do we do this? I think we need to store the result in a variable. Let's just do int. Status line bytes written. If status line bytes written is less than 0, then we return it. Yeah, I don't like this approach actually, because here, no, this is, never mind, this is a different case. What I was thinking is that, you know, here we're checking that if the return value that we get from these buffer write calls is less than -1, we always return -1. But what if in the future we ever need to have like -1, -2, -3 for different kinds of errors? But I think I'm just overthinking, and you know, a buffer writer will only have one possible error, which is running out of space, or you know, the output buffer not having enough space for what we want to write into it. So that's the only error that we need to handle. And the other thing is that, you know, the return value the error return value, the -1 that is returned by this function, is different from the one that we returned from this function, because this one is coming from the buffer writer, you know, like write calls. But here we have something completely different, which is an HTTP response serializer. So we don't need to return the same error integer. But in this case, since this function is calling these other functions, the serialized status line and serialized headers, which are of the same type, if one of the inner functions return an error, then we need to return the same error code. Even though, like right now, we only have one error code, which is -1, it's a good practice to just do it like this instead of like this. Just in case in the future that, if we want to do something like this, change this, we don't have to go here and also handle it. It's automatically handled. Bytes written, nope. So headers, bytes written. We just return it. Serialize headers. And I think this all looks good. We just need to test it. Let's go to main. Let's do a make clean. Okay, so I think we can just comment this part out. We can leave the panic. Test response serializer. We're just gonna have a character buffer that's like really big. We can just do 1024. Do we need to initialize it? Not really. Let's just do this. So how is this going to work? Let's do an HTTP response. Create HTTP response. We have an arena. Where's my arena? Okay, let's just create a new one. Arena create. So now response add header. It's gonna be the pointer. Content length, I guess we can do. Ooh, I remember now. Oh, maybe that could come later. So I think content length needs to be automatically populated by the server. When we send in like the response body, we need to have a utility function called send body that automatically, or I guess you could give it the body length and it automatically adds this header. This could come very later on. I mean, we don't have to implement it. We can, like for now, the developer which uses, I guess, like we're just imagining here. If, like if anybody's gonna use this server, but yeah, the developer has to add this header manually. Let's just use accept instead to be more realistic. Add header. I mean, it returns an int, but I don't care about the return value for now. So add another one, content type. And then, I guess we could just call serialize, right? We give it a response. We need to create a buffer writer. Init. I don't like this pattern, man. Why init? Why not just return it? These need to be dots. And it's not going to be init, it's going to be create. It takes in a buffer. And the size of buffer. Response. Okay, both of them need to be pointers. And I think that's it, right? Let's store bytes written. Is this an int? It is an int. Let's just debug print for now. Response length. We run. It's 0. That's not good. That's not good at all. Why is it 0? Oh, I know why. We're not doing any addition. We need to do this and this. Actually, why am I doing this? Like, what? I'm writing code like a monkey, dude. I could just do a plus sign here and that's it. I don't even need a variable. So 75. I mean, that's good. But now what if we print it? So we need to add a null terminator. We could just basically do bytes written, you know, to add a null terminator at the end. And I think then we can just print it, right? Surely this is gonna work. Very cool. Content type. Oh, we forgot one thing. One very important thing. Write status line. Write headers. Write body separator. We forgot to do this. Which we'll just copy from here. Did that even do anything? We need to do +2. I guess we could track the writer's position like we did here and just return the difference at the end, but we could also do this. But is it actually adding it? No? It doesn't look like it is. Oh, now it is. Why did it... What? Okay, now it's 77, which makes sense. We had a limit on the header length, right? So max headers, I think we have 50 or something, 100. What about the key length? Is there no limit on that? Oh, the limit I think is in the request parser, right? Header add Where's my header add? Yeah, it is here. So, yeah, there it is. Headers add. What's the max line length? And that's for the entire thing. Okay. Yeah, right now we don't have a limitation. Do we need to add a limitation? I am not sure. I think it's fine for now. Because the server is gonna be... maybe you could have like... what if you had like some vulnerable code on the server that, you know, fetches the value of a header from the database or something, which is populated by a user, and, you know, a user could have a value that's really long, and then the server could try to send that to clients and, you know, possibly break the browsers. Do browsers even have limits on the response headers? I am not sure. Maybe we could add it later on. I could do this. Add limit. The header line, I guess. Key plus value. So they're called key value in the other function, but here we're calling them name for some unknown reason. Okay. So this works so far. So let's remove all the headers and just run again. Where's my... Oh, can I do... I actually want to test a cool thing here. There's this head command, which... Can we skip lines? Print the first 10 lines of each file. What command can I use in Linux to print the beginning of a file? Print a range of lines, you know, from input or redirect, I guess. Yeah. So head and tail combo. Ooh, I like that one, yeah. I don't want to use sed. So head will basically fetch the first n lines from a buffer or from an input and print them. So I could do hello and, you know, add a new line and then do world, and I hope this works. And we can pass it to head. And then if we specify one line, it should only print a hello. So what we can do is, tail basically does the same thing, but it prints from the end. So if I do tail -1, it prints world. I need to learn these better. So here, I think what we can do is, let's just run server on its own. We don't care about this, so we're gonna skip this. So skip the first 2 lines. So does head by default like print everything? So we don't need head probably, we only need tail, right? Actually, we need to skip the panic. How do I skip the last line? I think that's not gonna be possible. Yeah, it has to be said. This is interesting. I've never thought about the way they worked. So I think head, the way head works, So the input comes as a stream. So as soon as it sees, like, let's say that head is reading from an input, which could be a file, it doesn't have to read the entire file before it starts printing. It can print, or it can start printing right away. As soon as it sees a new line, it will print everything before it. And it basically does that for every single line, which is nice for streaming. But for tail, I think the case is different there, because it has to reach the end of the input stream or a file or whatever before it can print. Because what if you give it, like, I want to print the last 6 lines? How does it know that, you know, like, let's say you give it 1 line. How does it know that this is the last line? You know, because you could still give it more. So it has to wait until the stream is completely done or over before it starts printing. And I think that's what set does, probably. So I think what we can do here is, I think we can still panic. We can remove this. Let's try to do this again. Yeah, this is printing panic, which is annoying. Let's just return -1. Or just return 0. Yeah, this works. So now we can do server and just feed it into XXD. And why did that not work? We're doing a redirect. Wait, what does debug print do? It prints to, oh, it prints to standard error. In Linux, how do I redirect to error into standard out? Because I think this pipe character only uses standard out. So what you print, basically in the terminal, I think there are 2 separate like streams, one called standard error and one called standard out. Not sure why we have 2. I think it's probably one for errors maybe, and one for, you know, other things. So merge, can you explain the operators? The operations, I mean, yeah, I can't type correctly. So standard in from a file. This redirects a file into a command, I believe. So we can do this. So the cat command, which basically prints the contents of an input, I think. You can give it a file with a redirect, and it prints it. Standard out to a file. So this redirects standard out into a file. 2 is standard error to a file. If I do, does it? So it's I guess it's shorthand for this, right? Because I think if you emit the number, the default is just 1, which is standard out. Yes, exactly. When no file descriptor. Okay, it's called a file descriptor. So standard out has file descriptor of 1. Standard error is 2, and then yeah, okay, 0 is input. That's cool to know. So append, if you do a double arrow, it's basically append. And what does... Oh, okay. So what this means is redirect standard error, which is 2, into 1. But if you just do 1 like this, it will think that it's a file. Like, here's an example. If I do echo hello and do 1, see, it creates a file called 1. I can open it here and it has hello. Let's remove it. And that's why we have the and. So if I do not like this, parse error. I think that's because I added space. I'm not supposed to add a space. So if I do this, it basically redirected it to standard out. And what if we do error? Same thing. Because I think the terminal treats standard out and standard error as the same thing. It always prints, contents that content that is written to these two streams. What if we redirect to 0, I wonder? It just prints it. What if we do 5? Okay, bad file descriptor. That makes sense. So now, going back to our server example, I think we can do this now. We direct 2 into... So how did this work again? So we need to redirect 2 into 1. And then we feed it into XXT. Exactly. So at the end, we can see here we have 0D, 0A, which is \r, \n, and basically twice. That's because end of status line and then end of head section, which is status line plus headers. Let's add our headers back. Potato is hot. We need to do make, run again. Let's just run server. Yeah, potato is hot. Very nice. So you know how we can know that, like, if this works? We can go here, basically, where we're sending a response. Where's my buffer? Right now we're writing like this response as like the whole thing as one string. So we can remove this. We already have an arena. So basically we can do content. We can try to send JSON. Actually, that would be cool. So welcome message is going to be a JSON. And it's going to be, message. Let's escape these. Don't come here again. Let's call it welcome JSON. And content length is going to be... Let's see what happens if we don't specify content length. I think it should work. We need to write it to a buffer. Bytes written. Where is this coming from? Oh, that's from up here. We don't need this code. So I guess let's do... It's an int, right? It's a size t. Yeah, but our function returns an int. That's because it also returns errors, but we don't need to handle errors for now. We're just testing. Let's do serialize head response. Where's my buffer writer? Size of buffer. Wait, what? Ooh. Yeah. I mean, let's just convert it into a character array. Does it really matter? Response is going to be a pointer, I think, right? What? Why is it complaining? Serialize head response bytes. Okay, now it works. So response bytes, we just send it. Right. Let's just do make and server. Let's send this here, go here, localhost. I think it's 6969, right? So accept the connection, but it's not. It keeps loading. That means that it's expecting more content. But why is that? Is it because we didn't specify content length? What if we specify it as 0? Would that fix it? I think that works. Yeah, it's the content length. I think it's required. Is content length required in a very minimal HTTP response with nobody? In HTTP 1.1, that is. So if we preview the response, why is it not printing it? Oh, there we go. What does this pen do? No, it's not required. But for 200 okay with nobody, you should include the content length 0. Client needs to know when the response ends, so it could send their next request. The client would wait for the connection to close. Okay, we're not closing the connection, I think. So it just waits. But what if we do this? Huh. Close. Client file descriptor. If we close the connection and remove the content length, would that make the... Yeah. Oh, it works. That makes sense. But how many requests is it sending? It's sending 3. Why is that? So 1 for localhost, 1 for the favicon. But what's the third one? I wonder. Anyways, we're not gonna close the connection. I think it's automatically closed anyways because... actually, I'm not sure how the kernel handles these things. We can look at, into them in the future. But let's get back to what we were doing. So let's do strlen. So welcome JSON. We need to convert it into a string. Body length. It's gonna be an int size t. Let's just do sn printf. So source. What? Let's look at the man page again. Where's my sn printf? Dude, why is the argument so confusing? Like, this makes no sense. So this is destination. Then we have size of destination, which is 12 in our case, but we can just use size of. And then we have format string. And then we have content length. Or no, body length. Yeah. Okay. I think it's ZU. Wait, why is this complaining? Oh, it's supposed to be like this. Buffer right string. We're gonna have to write the body manually for now. So we'll just do welcome JSON. Right here needs to be a pointer. I think that should do it. And we need to append here. Or add. Yo, sick man. Why is it loading like that? Yeah, but it works. I kind of want to try Insomnia. Oh, I don't have it installed. Can we install it real quick? How long is it gonna take? Let's just install the bin. Insomnia. It's Insomnia. I mean, hopefully this doesn't take long. Yeah, but this is very cool that it works. So, response builder is done. We can mark that. Response head builder utils. So that part is done. Let's add them here as well. So what's the next thing? No, this needs to be capital X. Wait, how does this work? Let's open with Chrome. Oh, where's my extensions? Hello? I don't have this installed for some reason. I usually do. Yeah, but it's not gonna work because let's do GitHub Dark. Allow access to files. Where is it? Where is it? Incognito, sure. And this one too. But these checkboxes don't work. What if I do a small x? It doesn't work either. I think it's because I have, it's in a list, right? Maybe it needs to be like this. Markdown checkbox. Wait, how does it work? Oh, it needs to be like this. It doesn't work. Capital X? Nope. Maybe this parser doesn't handle it. Well, anyways. I'll just keep it like this. Don't care. Response body builder utils. Yeah, we'll just come up with something simple. Maybe write raw body or something that, you know, just appends the content length header. Maybe we implement that, maybe we don't. We keep it simple and just let, you know, the user add the content length header manually. We'll think about that later. But for now, I think this works, and we have insomnia here, which we can test with. Let's open it. Continue, don't care. No, new request. Not an event stream. A request. We're gonna do HTTP localhost 6969. Yeah, I mean, it reads it and parses it, which means that things are working correctly. Oh, why does it hang sometimes? I think that's because we don't support concurrency yet, maybe? It's always the second time, so first time it works, second time it doesn't. Then it works again, then it doesn't. Then it works again, then it doesn't. It's probably because of concurrency. What if we just close them? I think that should fix it, right? Yeah, it does. So on average, it's like 20 milliseconds for the response. You know, I'm curious how this compares to... you know, Express. As to an npm init, npm install, save Express. Let's ask Claude here. Can you create a simple node Express app that has a single route that returns a JSON response? Message. Don't come here again. Okay, cool. Can do start. So yeah, around 20 milliseconds, maybe, you know, 10 or 15 at times. And that's with debug symbols. Yeah, it's around the same thing for Express too, which is pretty fast actually. I don't think it can get any faster than this, can it? Yeah, I feel like C should perform better in this case. I wonder why it isn't. I mean, yeah, they're both the same, it looks like. But anyways, that's all for today. Next time we'll finish up the response builder and then start working on, you know, something more interesting. Maybe before we do routing, maybe I'll start working on concurrency. That's, you know, the thing that I'm most excited about. But yeah, until then, see you next time.